Hi guys. Okay, so I want to continue with the circle angle theorems. So last week we did inscribed angle, central angle. We did angles between parallel lines, angles on congruent chords. Okay, what we're going to do today are the other set of angles that can happen around, in and around the circle. Okay, so the first one I'm going to do is theorem 8 here. Okay, so theorem 8 is when you have an angle formed by two tangents, okay? So again, recall, okay, if we have a circle, a tangent only intercepts a circle at one point. So an angle formed by two tangents would have to meet outside the circle, okay? So these two tangents, so this is the point where they would meet. Okay, you've got one tangent intercepting the circle at one point, another tangent intercepting the circle at another point. So for two tangents, they would have to meet outside the circle. Okay, so for angles that meet outside the circle, it's actually the same rule for all the angles that meet outside the circle, which is a good one. What it is when these two tangents meet up with the circle, do you see they kind of cut the circle into two separate arcs? This major arc here, right? And then the minor arc inside. Okay, so they cut it off into two arcs, okay? So this angle out here, okay, so let's call it X, right? So the rule would be that the angle X would equal, so let's call the arcs A and B. Okay, it would be half the difference of A and B. So the formula would be to do the big arc minus the small arc divided by 2. Okay, big arc minus the small arc divided by 2. Okay, so whatever this is, minus this, divide by 2, and you get the measurement of the angle on the outside. Now, because when two tangents intersect, when they intersect the circle, do you see it actually splits the circle into only two arcs? One big arc and the little arc in between would make up the entire circle, okay? It's because of that there's actually also an additional relationship. Not only if you subtract the arcs and divide by 2, you'll get the angles, there is actually a special relationship between arc B and angle X. B plus X is always equal to 180 degrees. So again, that's what this says here. The measure of the exterior angle and the minor arc are supplementary. So you can actually just pull it. This is just a shortcut. So you don't have to do the full formula. You could just say, oh, okay, I remember in this situation, the angle and the arc are supplementary, so I could do it in one step. So you have a choice. You could do it the long way or you could do it the short way, okay? But it would be the difference of the two arcs divided by 2, okay? So an example of that, okay? Let's look at this. So like right here, okay, so again, if we want to do it the formula way, right? So I do know that this big arc here is 220. Again, that means I can find the small arc because the total of these two arcs is 360. So do we see this small arc would have to be, 140. Okay, so that small arc is 140 degrees. So that means angle X would have to be 220 minus 140 divided by 2, right? So that's 80 divided by 2, which is 40 degrees, okay? Notice, here I have 40 and 140, right? Aren't those supplementary? So I end up getting, so I could have gotten angle X by just subtracting the minor arc from 180. Either way, so the rule fits, you subtract the two arcs and divide by 2, or the supplementary shortcut also fits. So this one right here, I'm just gonna do the supplementary shortcut. X would have to be 100 degrees, right? Because the minor arc and the exterior angle have to add up to 180. Okay, and if I needed to, I could get the other arc by just subtracting from 360, okay? All right, so theorem number 9 is basically the same theorem. It's when two secants meet. So same thing goes. If two secants meet, they have to meet outside the circle. But remember, a secant crosses through the circle in two spots, right? So do you see that secant crossing the circle in two spots? Draw another secant. It would also have to intercept the circle in two spots, right? So this is a little different than two tangents because do you see you actually get 4 different arcs that the circle gets cut off into? Okay, so it's not, we don't have that supplementary shortcut because you have 4 arcs adding up to 180, not 2 arcs anymore. Okay, so what are the arcs we're talking about? Well, it's the arcs in between the angle. So if we just forget about the rest of the circle and follow this out, do you see there's a big arc here? I'll call it A, right? So A would go from here to here. Keep going towards the angle. There's a little arc in between them. Let's call it B. And then that'll get you to find that angle X. So those would be the arcs. It's still the same rule. It's still A minus B over 2 will get you what X is equal to. So it's still the difference of the 2 arcs. The only difference between this and the other one is there's no supplementary shortcut. You have to go the formula way, okay? So let's do some examples with that, right? So here I have the big arc, the little arc, the angle. So I'm just gonna follow the formula, right? So that means the angle X has to be the big arc minus the little arc divided by 2, right? So here I get 70 divided by 2, so the little arc has to be 35. Okay, so notice clearly not supplementary, but it's the difference of the 2 arcs divided by 2, okay? Here do you see we're not missing the angle, we actually have the angle, but it's still that same formula because you do have the outside arc and the inside arc, right? So here, it's not gonna be angle X, it's actually gonna be 50 equals 200 minus X divided by 2, right? If you're filling into the formula, this time you have the angle, you're missing one of the arcs. So if you cross multiply here, you get 100 equals 200 minus X, and if you go to solve here, you get negative 100 equals negative X, so X is 100 degrees. Okay, so that would have to be 100. Quick check, 200 minus 100 is 100, divided by 2, you get 50. So you know you're right, okay? Again, another situation that really deals with the same formula is when you have a circle and you have one secant and one tangent, okay? So you have, again, they would have to meet outside the circle for this to happen. So remember, a tangent is at 1 point, a secant intersects at 2 points, right? So do you see in this situation, it actually cuts the circle into 3 different arcs, okay? But it's not 3 arcs I need, it's only 2 I need, okay? So the 2 I would need is, do you see if you look at the end of the tangent and the end of the secant, connect those, that's your big arc, right? Follow the angle in, and do you see that's the little arc here? So it's this arc that would have nothing to do with the problem because it's outside the angle. But then again, it's still the same formula. X equals the difference divided by 2. So you can make a rule of thumb for yourself. Anytime things meet outside the circle, it's always going to be a difference divided by 2. So an example of that looks like this one, right? So here I'm given 80 and 20, which is 80 is the arc I need, right? 20 is the other arc I need. I don't need I could find this arc now if I really wanted to, but I don't need it. I just need the outside and the inside. So this is gonna be angle X equals 80 minus 20 divided by 2. So that angle is just gonna be 30 degrees, okay? Second situation, you could be missing one of the arcs. Again, just put it in the formula. This time I have the angle, 30 equals the outside minus the inside divided by 2, right? Cross multiply, solve for X, and you get that that has to be 110, right? So this has to be 110. You could do a quick check. 110 minus 50 is 60, divided by 2 is 30. So all of these involve the same formula, subtract and divide by 2, okay? All right, now another situation is going to be a tangent and a chord, okay? So a tangent and a chord would be different. A tangent, in order for a tangent and a chord to meet, they would have to meet, so here's a tangent, they would actually meet right on the circle, okay? Directly on the circle, okay? Now, we already know of a different angle that we did last week that also meets on the circle. Doesn't an inscribed angle, okay, isn't the vertex right on the circle? Okay, so that's this situation, right? So like, let's say we're talking about this angle X, right? And I'm gonna call this arc A, this arc B, and while we're at it, let's just call that one angle Y, okay? So similar to an inscribed angle, the vertex is on the circle, so we just do half the arc. Same thing here. These meet on the circle, so just like inscribed angles, it would be half the arc. So I have two different angles here. Do you see angle X, okay, would be half of angle A, and angle Y would be half of angle B. Okay, so it's gotta be, so if you follow this out, right? If you follow the chord out and go all the way back up to the angle, you know which arc you're having, right? If you're talking about angle Y, right, follow the angle out and go all the way back up, you're talking about half of angle B, okay? So an example that would look like that, okay? We have got, so here, I know this arc is 120. I'm trying to find this angle. Again, this angle right here is right on the circle. So all I have to do is a half of 120. So angle X is 60. Okay, I could give you the reverse. I could give you the angle and you have to find the arc. Okay, this one you have to do in 2 steps because you see the angle you're given isn't the angle that corresponds to the arc you want to find. So you have 2 choices. You could either find this angle, which again, it's a straight line, so you know it's supplementary, right? So you would know that angle is 110, and you know that 110 has to be half of the arc it goes out to. So in this case, you're just gonna reverse it. You're gonna double the 110, and arc X has to be 220. Okay, the other thing you could have done is you could have said, okay, if the 70, I know this 70 has to be half of this arc. So that means this arc is 140. And if I subtract from 360, don't I still get 220? So there's really 2 ways you could have done it, okay? Now, a variation, a special case of this, it's actually number 14. I'm skipping to number 14 here just because it really is a variation of a tangent and a chord, okay? All the variation is, you see, if I take that same tangent, right? Okay, and where it meets up with the circle, if I draw the chord as a diameter, make it a special chord, make this chord the diameter, right? Okay, then I wouldn't need any numbers in this picture. If that's a diameter, do you see I automatically know that this arc right here has to be 180? So that means when a tangent and a diameter meet, it would always meet at a right angle on either side. Okay, so a diameter and a tangent are always perpendicular to each other. What you could do with that one if you want also is, do you see it wouldn't have to be full diameter. Do you see if you only drew it as a radius? Do you see it would still have to meet at a right angle? It wouldn't matter because a radius is just a shortened diameter. So if I were to extend that radius out, it would still have to be 90 on either side. So that's just a special case. So you do get a 90-degree angle there, okay? So here's the thing. When you get a 90-degree angle, it also means that some extra things are on the table. So look at this one, right? So let's assume we know this is the center, right? So if we know this is the center, we know this is a radius and a tangent meeting. And if a radius and a tangent meet, we could automatically mark that a right angle. So do you see, once we have a right angle, all I have to do is make an extra line here and I get a right triangle, which just means Pythagorean theorem is on the table. That's all that means, is if I know this is a right triangle, I could find the missing side by doing the Pythagorean theorem. So I could do x squared plus 12 squared equals 15 squared, okay? And then finish it up on this one. You're just gonna get x equals 9, okay? So this one here, same kind of thing. This time it's full diameter, but again, when a diameter and a tangent meet, they automatically meet at a right angle, okay? Which again means I'm dealing with a right triangle. Now, do you see you don't have this full side? okay? But you do. You do have the full side because remember, from here to here is a radius. From here to here is the same radius. So you actually know from there to there is also 6. So when you go to do the Pythagorean theorem, you're going to do 5 squared plus 12 squared equals x squared on this one. Okay, so just Pythagorean theorem is on the table here. So when you finish the Pythagorean theorem, you end up with 13 as that side. Okay? All right, final theorem. Okay, so number 12 is not a theorem. It's just saying that if you have a secant and a chord, there's no formula. So I don't even know why they put this box in here. If there's no formula, there's no picture. So don't even worry about that one. So the final one will be number 13. Number 13 are just 2 chords. So if I draw any 2 chords, do you see they would have to intersect inside the circle? Okay. So we saw we have one formula, it's half the difference if they meet outside the circle. When it meets right on the circle, it's just half of the arc, okay? When it meets inside the circle, it is just gonna be this time half the sum of 2 arcs, okay? So you say, all right, I need to add 2 arcs. How do I know which 2 arcs I'm gonna add? Well, it depends on what angle you're looking for. Let's say this is the angle I'm looking for. Let's call that x, right? Well, you also know because of vertical angles, wouldn't this angle also be equal to x, by the way? So when you find one angle, you're really finding 2 every time because of the verticals. Okay, so which angles would they deal with? Well, if I follow this angle x out, doesn't it cut through this arc right here? So that angle goes out to, let's call it arc A. If I follow this angle out, it goes out to angle B, right? So for angle X, it would be A plus B divided by 2. So this time we're doing a sum and we're doing adding 2 arcs and dividing by 2. Now, if the arcs I wanted, let's say it was this angle, let's call this angle Y here. Do you see? For this angle Y, I would need this arc here, let's call it C, and I would need this arc here, let's call it D. So if I wanted angle Y, it's the other 2 arcs I would be adding. Okay? Again, if I really needed angle Y, I still could find angle X first, and then it's just supplementary to angle X, so I could do that as well. All right, so let's just finish up with that example. Okay. So here, if we look at number 13, okay, so number 13, the angle I'm trying to find is X. If you want to mark the one across from it as X, so that you remember the 2 angles you would need are the 2 angles those go off to, which is what I have, right? Don't I have, if I follow this out, it goes to the 70. If I follow this out, it goes to the 30. I have everything I need to get X. I do 70 plus 30 divided by 2. So that means angle X has to be 50 degrees. Okay. This one right here, I'm looking from one of the arcs, right? So do you see I have this arc, right, that goes to this angle? Or I'm looking for this arc that goes to this angle. I have this arc that goes to this angle. Do you see actually, even though I have this angle right here, this angle would involve these 2 arcs. So I need, if I am looking for this arc, I need this angle. But do you see, because of supplementary, I can get this angle? Don't I know that these 2 angles have to be 80? So again, I have enough information, right? So that means the 80-degree angle has to equal the sum of the 2 arcs here. So I'm just gonna make a little equation, 160 plus X divided by 2. So here I get, oh, does it somehow end up being, maybe I put in the wrong numbers here. Yeah, because somehow it ends up equaling 0. I think I made a mistake on this original angle. Okay, so let's just call this one, actually, let's change this, and we'll call this 150. Okay, so if I call that 150, this will work out. So here I get 160 equals 150 plus X, so X has to equal 20. Okay, so really 3 theorems here we have to remember. If you have 2 angles meeting outside the circle, you're going to be subtracting 2 arcs and dividing by 2. If If the two things meet right on the circle, you're just going to be taking one of the arcs and dividing by 2. And if the angles meet inside the circle, you are going to be adding 2 arcs and dividing by 2. Okay, so in Wednesday's lesson, we are going to be doing some examples from page 7, 29, and 31 in the packet. So again, you don't have to print up the whole packet. If you just want to print those pages ahead of time, those are the examples we're going to be doing in Wednesday's lesson. Okay, thanks guys.